Hi, and welcome back. So in this video, we will talk about the present value of compound interest. I'll do some questions. Before I do the questions, I just want to get started with the formula here. I've already written the formula, but I just want to show you how exactly we got here in terms of how we got here from the future value formula. So it's not a new formula. It's the same old formula that we use for future value. It's just rearranged to solve and isolate PV so that we can solve for present value. So the original formula was future value is equal to present value multiplied by 1 plus I to the power of n. Now, in order to isolate present value and in order to solve for present value, what we'll have to do is just divide both sides by 1 plus I to the power of n. That'll cancel out 1 plus I to the power of 1 plus I to the power of n on this side, and we'll be left with present value is equal to future value over 1 plus I to the power of n. Now we can also write this formula as PV is equal to future value into 1 plus I to the power of negative n. Because we know that a fraction is, if reversed, it's negative. It becomes a negative exponent. My bad. Okay, anyways, excuse me. With that being said, let's get started on question 1. So question 1 states that Alice received a loan to start her small business with the condition of repaying the loan within 5 years. So she had to repay the loan within the 5-year time frame she had. The interest rate on the loan was 3% compounded quarterly for the first 2 years and 3.5% compounded monthly then after. She settled the loan in one single payment of $55,000 at the end of 4 years. What was the original / principal amount Alice received and the amount of interest charged on the loan? Okay, let's get started with that. So the first thing we do with a time value of money question is draw a timeline. So we know that the interest rate charged on the loan was 3% compounded quarterly. So it's for the first 2 years. So it's 3% quarterly. So we could say year 1, year 2. So year 1 end, year 2 end, year 3 end, year 4 end, and so on. And from here onwards, all the way onwards, it's 3.5% monthly. Now, the thing we know here is that she settled the loan at year 4. So here she settled the loan by paying $55,000. So we need to figure out what was the original and principal amount, right? The original and principal amount. So in order to do that, now we've got a timeline and we've broken down the question, technically solved it. Let's figure it out. So the first step is to figure out your present value here. What will it be worth? The reason why we're doing this is because, and not going all the way, is because the interest rate is changing at the end of year 2. Because for the first 2 years, it's compounded quarterly. So there's 4 times a year and 4 times a year. And for the next 2 years, because she's paying it in 4 years, it's 12 times a year and 12 times a year, right? 4 times, 12 times a year. So it's 55,000, and we need to find the present value here. Whatever we get, whatever this value comes out to be, we take that value and we find this final present value, which is the value of her not an investment, of her loan, which is worth today. So what she borrowed today, that's exactly what we'll get. So let's begin with that. Now, we can use the BA2 plus financial instrument. You can use the time value of money, NI, PV, PMT, FV. I'm just going to use a formula so that you understand it better, because you could, figure out this. The calculator does it, the math in there. I don't like that. I like it when it's hands-on and you get to understand it with the equation. So anyways, so with that being said, let's get started here. So the first PV1 is equal to our future value, which is 55,000, right? And we just divide that by 1 plus our interest rate here is 3.5%. And it's monthly, so the compounding frequency is monthly. So that's 12. And our N, remember our N states M times T. So your M is going to be a compounding frequency, which is 12, and T is your time frame. So how in years, in number of years is. So how many number of years do we have? We have 1 12 times and 2 12 times. So it's 2. So that's where we're going to have, this is going to be equal to 24. So now we can just use our calculator to solve for the 55,000. Oops, 55,000. And then we'll get a number here. So let's do that. Let's get that started with. So it's 3.5. Divide that by 100 to change it into a decimal. Add 1 to that. Whoops, sorry. 3.5. Divide by 100 to get into decimal. Divide that by 12. And that's just this component. Then we add 1 to that, and we get 1.0029166667. And we put that to the power of 24, and we get 1.072398914. Now I'm just going to save this in memory so that when we divide it by 55,000, we get the right answer. So I'm just going to do storage and 1. Okay, recall memory. Okay, got it. Okay, we got it. It's stored. So now the equation states that it's 55,000, which is our future value. Divide that by our stored value. And we will get 51,286 and 88 cents, 521. Now, I'm also going to store this as number 2 because this is our next present value. So now our equation for PV2, to find PV2, states that it's $51,286.88 approximately, 89 cents approximately. So that 51,000 is the value here today. Not today, 2 years in to the loan. So it was 55,000 at the end of year 4. She paid that. So at the end of year 2, it's $51,286.88. Now we just divide this by the compounding frequencies that we have. It's 1 plus 3% compounded quarterly to the power of, again, M times T. M in this case is 4 times T. Again, it's twice, so it's 2. So we're going to have 8 here to the power of 8. And let's just do that quickly. So I'm just going to rewrite 51,286.88521. And let's solve this a little bit quickly now. So it's 3% divided by 100 and divide that by 4. So we get 0.0075. And we're going to add 1 to that. So we've solved this. Now we're going to do the power of 8. 4 times 2 is 8. And we get 1.061598,848. And I'm just going to store that under 5 for now. And then we're going to do recall number 3. Whoops, recall. Oops, recall number 2. Okay, it was number 2. So that's our value that we got for the first present value. Now we're just going to divide that by recall number 5. And the total value that she borrowed, the principal amount, was $48,310.98 approximately, right? So now we've got the principal amount, which is half the question. Now the other half states that you have to find the amount of interest charged on the loan. And we know that if we simply look at this formula, which is future value is equal to present value multiplied by interest. So what it's trying to say, it's future value is equal to present value plus the amount of interest, right? This is amount of interest, not the percent of interest, amount of interest. So it's very simple to find it. Now we know that a future value is 55,000 because that's what Alice paid. So it's 55,000 is equal to present value, which is $48,310.98 plus the interest, which is the interest amount in this case. Now subtract $48,310.98 on both sides, and you'll find the interest amount. So I is equal to 55,000 minus 48,310.98, which will give us, if we do this right, 55,000 minus 48,310.98, and we have an interest of $6,689.02. So this was the principal amount she borrowed. This was the amount of interest she paid, and in the end, she ended up paying $55,000 for the loan that she borrowed. Now that's it for question 1. Let's go on to question number 2. Okay, so question 2 states that Sarah just graduated top of her class. Don't we all want that? And as a reward, her parents decided to reward her with a monetary compensation. She was given the following options. Sarah will receive $10,500 today, or Sarah will receive $7,000 today and $4,500 2 years from now. The money earned 2.5% compounded semi-annually. Which option will give Sarah the maximum monetary compensation today? Interesting. So option A, we don't need to do anything for it. She'll get $10,500 today. But with option B, we do need to compare it because she's only getting $7,000 today. And we need to figure out what would be the value of $4,500 today, because this $4,500 she's going to receive in 2 years from now. So what would be the value of it today? And note that we all are also given the information that the $4,500 was compounded at 2.5% semi-annually. So with that being said, option A, just to write it down, it's $10,500. And what we want is the maximum, right? So whatever gives us the most value today, or whatever gives Sarah the most value today. Option B, right? Option B, we've got $7,000 today. But in addition, we have to figure out the present value of $4,500, which we will get in 2 years from now. So let's get started with there's only one component that we have to do here, which is to find the present value of $4,500. And in order to do that, we'll just use our equation. Present value is equal to future value over 1 plus I to the power of n. So our future value is 4,500. Our interest rate is 2.5% compounded semi-annually, and it's 2 years from now. So our M is 2 and our T is also 2. So we have 4. 2 times 2 is 4. Therefore, if I just rewrite it, I'll just write it at 4,500 into 1 1 plus 2.5% divided by 2 to the power of 4. Right? Now, let's solve this. So it's 2.5 divided by 100 to get into decimals. Divide that by 2. So it's 0.0125. Add 1 to that. So we've solved this portion of the equation to the power of 4. And we have found 4,500 divided by 1.050945337. Wow. Now I'm just going to restore this number under 9 for now. So I'm just saving it in memory so that I don't have to retype it. Now we just take 4,500 divided by 1.050945337, and it tells me that the value of 4,500 2 years, so today it's $4,281.85, so 86 cents approximately. So now the value of the 4,500 today is 4,200. So option B was that you get 7,000 today, and on top of it, the value of 4,500 turned out to be $4,281.86. So 0.86, 1, 8, 8, 2, and 7 and 4 is what? 13? Oh, no, not 13. 7 and 4 is 11. So $11,281.80. So comparing that, so that being said, therefore, option A is less than option B. Sarah should go with option B, right? Therefore, go with this one. Option A was 10,500. Option B is $11,281.80. Therefore, choose option B. Choose option B. So that solves the present value questions that I had prepared. If you have any questions regarding this video or any other things, write it in comments. Let me know. If you like this video, please share, subscribe, and like my channel. Like this video, subscribe to my channel. I would appreciate that. Thank you, and have a nice day.